When we picture a factory, we usually expect a lot of order, like assembly lines, quality control, raw materials coming in, and finished products rolling out exactly on schedule.
Right, everything perfectly calibrated and running smoothly.
Exactly.
Yeah.
But imagine if someone just hijacked the central control panel. Suddenly, the factory starts churning out millions of defective, totally useless parts.
Yeah.
The assembly line jams up.
Yeah.
The raw materials are completely hoarded. And, well, the whole system inevitably crashes.
And I mean, the most dangerous part of that scenario, you don't even realize the factory is failing until the final products just completely stop shipping.
Which is terrifying. And that is exactly the mechanism of acute myeloid leukemia, or AML, when it takes over your body's bone marrow. So welcome to today's deep dive into the source material. We are exploring AML to help you understand not just how this aggressive cancer sneaks up on you, but its fascinating origins before birth and the emotional shockwaves it sends through families.
Yeah, it really is a silent attack. I mean, to see this in action, let's look at a recent medical case report of an 18-year-old. His symptoms seemed, incredibly common at first, just nausea, fatigue, some unexplained weight loss.
Hence you'd easily brush off, right?
Exactly. But his blood work revealed an absolute crisis. He had extreme leukocytosis. So his white blood cells had multiplied wildly to 161,000, and he was suffering from severe anemia.
Wait, 161,000? That is insane.
It's massive. And to understand why that happens, let's go back to your factory analogy. The bone marrow is a really confined space inside your bones.
Okay, I'm with you.
So when those defective parts, the immature leukemic cells, multiply to that extent, they physically crowd out the healthy cells. They just consume all the nutrients in physical space.
Making it biologically impossible to manufacture normal red blood cells or platelets, I'm guessing.
Spot on.
Which explains the extreme anemia and those sudden life-threatening complications. Because without red blood cells to carry oxygen or platelets to clot your blood, your organs are essentially suffocating.
They are, and they're incredibly vulnerable. That rapid progression is just devastating. Like the tragic real-life case of Caitlin Leggett. She was only 24 years old.
Oh, wow, so young.
Yeah. She actually achieved remission after a stem cell transplant and managed to raise 127,000 pounds for treatment abroad. But then she suffered a sudden fatal brain bleed just days later.
Gosh, that is heartbreaking. It really shows how aggressively and unpredictably this disease can undermine the body's infrastructure.
It does.
But Caitlin's story also reveals something extraordinary, didn't it? During her illness, she and her sister Grace discovered they were actually identical twins.
Yes. And that genetic link opens up a fascinating window into some groundbreaking research from the Institute of Cancer Research regarding how this cancer even starts in the first place.
Right, the fetal origins part.
Exactly. The researchers found that identical twins with leukemia share a very specific genetic anomaly called the ETV6RUNX1 gene fusion.
A gene fusion, so like a biological typo.
Yeah, basically. Two separate genes break and fuse together incorrectly, which creates a rogue set of instructions. And what's mind-blowing is that this specific typo actually occurs in the womb.
In the womb. How does that work for twins?
Well, it starts in one fetus and then spreads to the other twin through the shared blood supply of their placenta.
Wait, let's unpack this for a second. If you're a twin and you share that exact same rogue mutation from before you're even born, are you both just automatically destined to develop the exact same cancer?
It's completely logical to assume that, but no, actually. The researchers used a technique called single-cell genotyping.
What does that involve?
It involves sequencing the DNA of individual cells, just one by one. This allows scientists to map out a microscopic family tree of the cancer's evolution.
So they can see exactly when and where the rogue cells diverge.
Precisely. And the genotyping proved that while the twins share that initial founder mutation from the womb, their cancers evolve uniquely after birth.
Because they are living separate lives.
Right. Once they're born, their cells pick up completely different secondary mutations.
That is wild.
Yeah.
Which means the origins are deeply intertwined, but so is the fallout. I read that Caitlin's twin Grace actually left her job to become her full-time caregiver.
Yeah, when a young person gets leukemia, it fractures the entire family structure. The siblings in particular often become the invisible casualties in all of this.
For sure. Treating cancer isn't just about the patient. It's an earthquake that damages the whole house. And the siblings need structural support, too.
Clinical research on pediatric interventions really highlights this. Siblings experience profound isolation because, well, all parental energy is suddenly diverted to the hospital.
Which makes total sense, but it leaves the other kids struggling.
Exactly. We see this manifest as intense behavioral issues or a sharp drop in school performance. The psychological toll is immense.
But there are structured ways to help them process that trauma, right? The research on play-based cognitive behavioral therapy is really fascinating here.
It really is. Therapists use what's called behavioral rehearsal with medical toys, or they even have kids design superhero masks.
I love that. And the mechanism behind why that behavioral rehearsal works is so critical. A hospital is a chaotic, terrifying environment where a child has zero agency.
Absolutely zero.
But by acting out the treatments on toys or reading books like Gaspar Chemo to demystify the process, the therapy drastically reduces their cognitive overload.
Exactly. They aren't just playing, they are mapping out a sense of control.
Yeah.
The superhero masks help kids literalize their internal defenses against anxiety.
It gives them a psychological anchor when their world feels totally out of their hands.
It reinforces that treating cancer requires a truly comprehensive approach. You have to address the aggressive biological reality alongside the profound invisible wounds inflicted on the family.
So true. From its stealthy takeover of our bone marrow factories to its fetal origins and just the heavy emotional toll, AML is a uniquely complex disease.
It really is a relentless battle on multiple fronts.
Which leaves us with a final thought for you to ponder. If identical twins share the exact same leukemic mutation from the womb, but their cancers develop entirely different secondary mutations after birth, what hidden everyday triggers in your own environment might be holding the keys to turning our genes on or off?